Welcome to episode 54 of Pulse of Physiology. I'm your host, Dr. Jim Davis, and today we're exploring carbon dioxide transport. This is the essential process that moves carbon dioxide from tissues to lungs for exhalation. By the end of this episode, you'll understand how carbon dioxide is transported in the blood, the role of something called carbonic anhydrase, the chloride shift, and how carbon dioxide influences pH balance. So let's get started. Carbon dioxide is carried in the blood in three primary ways. The majority of it is transported as bicarbonate, which is HCO₃ negative. The majority of carbon dioxide is converted into bicarbonate, which is a key buffer in acid-base balance. Next, we have carbon dioxide that's bound directly to hemoglobin, but this binds at a different site than oxygen, and as we'll talk about later, when carbon dioxide binds to its binding spot, it actually makes it more difficult for oxygen to bind to its binding spot. And then finally, there's a small amount of carbon dioxide that is transported freely in the blood as it is dissolved in the plasma. Now, as I mentioned earlier, the most significant way that carbon dioxide is transported is through its conversion into bicarbonate via the following reversible reaction. In tissues where there are high levels of carbon dioxide, the reaction shifts to the right. And so this reaction is carbon dioxide plus water ultimately turns into carbonic anhydrase, and then that carbonic acid, with the help of carbonic anhydrase, breaks down into bicarbonate and hydrogen ions. So in the tissues, the reaction shifts right, where we produce a lot of bicarbonate and hydrogen ions. Now in the lungs, where there are low carbon dioxide levels, this reaction shifts left, ultimately converting bicarbonate back into carbon dioxide that we exhale. This reaction is catalyzed by the enzyme carbonic anhydrase, which speeds up carbon dioxide conversion. Now, at the tissues, carbon dioxide is produced through metabolism and must be transported to the lungs. So as I mentioned earlier, some carbon dioxide dissolves into the plasma and remains there. Some of this carbon dioxide will then diffuse onto the red blood cell and bind to hemoglobin, forming a compound called carbaminohemoglobin. And then most of the carbon dioxide will diffuse out of the plasma onto the red blood cell, and there it will react with water to form carbonic acid, like I mentioned a moment ago. And then carbonic acid will dissociate or break apart into bicarbonate and hydrogen ion. The hydrogen ion binds to hemoglobin, which reduces the affinity between oxygen and hemoglobin, and so this promotes oxygen unloading. And oftentimes this is referred to as the Bohr effect. The bicarbonate that's formed will actually exit the red blood cell in exchange for a chloride ion, and this is called the chloride ion shift. And the reason that this happens is to maintain the charge balance on the red blood cell. Now, once we get to the lungs, the process reverses, and this allows carbon dioxide to be exhaled. So bicarbonate re-enters red blood cells in exchange for a chloride ion. This bicarbonate then combines with hydrogen ion to form carbonic acid, which then breaks down into carbon dioxide and water. Carbon dioxide will also dissociate from hemoglobin, and then this carbon dioxide will diffuse into the alveoli and ultimately be exhaled. Now, it's important to know that carbon dioxide is a weak acid, meaning that its levels directly affect blood pH. So if you have more carbon dioxide in your blood, that means you have more hydrogen ion, which means you have a lower pH. So this is referred to as acidosis. However, if you have reduced levels of carbon dioxide, this means that there will be less hydrogen ion in the bloodstream, resulting in a higher pH or alkalosis. Now, your lungs play an important role in helping to maintain blood pH. So you can hyperventilate, which means you're increasing your breathing rate, and this will ultimately lower carbon dioxide levels, which will raise your pH. You can also hypoventilate, which is a decreased breathing rate, which retains carbon dioxide, and this will lower pH. So to summarize, carbon dioxide is transported mostly as bicarbonate, but it can also bind to hemoglobin and stay dissolved in plasma. The carbonic acid bicarbonate buffer system regulates carbon dioxide conversion between tissues and lungs. The chloride shift maintains charge balance during carbon dioxide transport. Finally, carbon dioxide plays a major role in pH regulation, which we'll talk about more later on in the semester, where hyperventilation raises pH and hypoventilation reduces it. And so that's it for episode 54 of Pulse of Physiology. I hope this episode has helped clarify how carbon dioxide is transported and its role in acid-base balance. So join me next time for episode 55, where we'll explore pulmonary diffusion and gas exchange. Until then, keep questioning, keep exploring, and stay curious.